Building information modeling. In the next few minutes, I will give you an overview about building information modeling, or in short, BIM. What is it? How does it work? Do we really need it? Before I start talking about BIM, I first want to take a look at the problems we face today whenever we have to deal with construction projects. For this, I have selected an example many of you should already know, the new airport in Berlin. Originally, the opening was scheduled for October 2011, and the construction cost was estimated at 1 billion euros. As of today, these figures look much different, meaning an opening in autumn 2017 and construction costs of approximately 6 billion euros. What are the reasons for the significant delay and the six-fold increase of the cost? The main problem was the smoke extraction of the building, which has been incorrectly designed and built. Unfortunately, this became clear at a very late time, meaning just before the completion of the building. There were also other problems with the static. For example, fans have been installed underneath the roof, which were significantly heavier than planned and taken into account by the structural engineer. Also, even rather trivial points have caused problems, such as escalators, which are too short. Let's take a closer look at the design phases of an object, starting with the preliminary design up to the construction supervision and project support. First, we take a look at the possibilities of making revisions or changes. At the beginning, we still have a relatively high influence on performing changes. However, this changes significantly with the construction progress, and during the execution phase, we have almost no possibility of performing changes, since the object is already under construction. The curve for the modification expenses looks different, but unfortunately not much better. Changes done in the early design phase cost relatively little. However, during construction, these costs become more and more expensive. This is clearly demonstrated by the example of the airport in Berlin, where the smoke extraction had to be redesigned and rebuilt shortly before completion. And this is a core issue in the way we often work today. The real construction already begins before all project participants have completed their designs. In many cases, this leads to problems on the construction site, for example, because of collision points of non-coordinated trades or because of regulations and laws which have not been taken into account. These problems must then be corrected within the framework of the building construction and involves additional time and cost. This applies not only for the executing companies, but also for all other project participants, such as architects, designers, and building owners. The problems described are partially due to the fact that we have many project participants involved in building construction. Take, for example, a larger residential complex. First of all, we have the client, then the architect, the specialist planners, authorities, construction managers, and executing companies. The client is, of course, in contact with the architect, who is in turn in contact with the specialist planners. These are in contact with the authorities and the construction supervisors, and so on and so on. In the end, everyone speaks to everyone, and there is a high risk, especially the larger the construction project, that not all parties involved receive all information relevant for them. And here is the starting point of BIM, as a 3D building data model is generated with BIM and all project participants have access to this model. Thus, the architect no longer distributes plans manually to all parties. It's the opposite. All parties have direct access to the same databases, meaning the building data model which is stored, for example, in a cloud. This means that all parties involved have an overview of all trades and informations which also promote cooperative working. The BIM building data model is more or less the heart of a construction project. A detailed 3D building data model is already generated at the beginning of the design process, and this model is supposed to represent the digital twin of the real building to be built later. The realization of the real building takes place only when the digital twin has been fully designed and coordinated by all project participants. By doing so, possible problems and collision points can be detected and solved at an early stage of the design. In addition, the model can be used to perform simulation calculations, for example, to try out different energy concepts. At an early stage, the digital twin determines what will go into the building. This helps to avoid amendments and by this increase the degree of the time schedules. Now, the objection may be that we have already designed buildings in 3D for years, so what is really new about BIM? BIM takes a step beyond the classic 3D approach because the BIM model is created with components and products that have large amounts of parametric data, or let's call it specific product information attached to it. This is something I will talk about on another slide. The building data model generated in an early phase is also used in the course of the design and execution phase. It's also used for the facility management. In case of a later reconstruction of the building, the designers will have all building data available. Because of all of this, all project participants always have the complete building information available, and this allows the model to be used throughout the complete building lifecycle, including a possible demolition. As explained before, BIM goes beyond the classical 3D model, and the BIM building data model is also used for scheduling and recording the construction progress and construction costs. For this reason, we are talking about the 4D axis for time and 5D for costs in addition to the known 3D. To summarize what we have learned so far, building information modeling stands for building data modeling, and it uses parametric building products which go way beyond the classic 3D models. First, we do the digital design, and only when this has been finalized, we start with the real construction. BIM is used for the entire life cycle of a building, starting with the first design up to the facility management. The loss of information, for example caused by the handover of the design to the executing companies, can be eliminated. And most importantly, BIM is a working method, not a software tool. I always compare it with driving. Driving is a method of moving around, but to perform this, I will need a car. In order to do BIM, we need the appropriate software tools, and there are several suppliers and solutions in the market, of which I'll list a few examples. For the calculation and design of the technical trades, we will also need certain software solutions, which will need to have clearly defined interfaces to the data of the building models. As before, I have shown a few examples of software suppliers from the field of building technology. These software tools are therefore the first step to perform the BIM method. However, in addition, we will also need BIM-suitable product data from manufacturers such as REHAU. In the following, I will briefly show a simple example of how the difference between BIM and classic 3D drawings look like. Take, for example, a Lego brick. In 2D, you have to draw the individual views of this Lego brick separately so that they can be displayed accordingly. In 3D, you draw the Lego brick just once with its 3 axes, and it can be rotated as desired. With BIM, you have again the Lego brick in its 3D view, but you also add lots of additional data and attributes to this file. In this example, you can find the name of the brick, the color, the dimensions, possibly the cost, the weight, the material, and the date of production. The latter can, for example, be relevant for products which have only a limited lifetime, or which are relevant for maintenance intervals. As you can see, the datasets for BIM contain much more information than the classic 3D drawings, and you can add a variety of attributes which are relevant for the design of the building. What can REHAU offer you regarding BIM? For several systems, REHAU has created BIM datasets for use with Autodesk Revit software. In the field of building technology, for example, we have implemented the wastewater system REHAU Piano, as well as various pipe systems. If you are interested in our datasets, please enter www.rehau.de/datensats in your browser. By doing so, you can access the download area of the REHAU datasets, where you can find, amongst other things, the REHAU BIM data. Click on the download button and then enter your contact information in the window that will open. We will only use this information to inform you about updates to the REHAU BIM data. Now, you may ask yourself, do I have to deal with this at all, or is BIM only a buzzword which will disappear sooner or later? Have a look at the world map. Coloured are the countries where BIM has already gotten a more or less important role. In many of the countries, BIM is already or will be required for certain building types, mainly in the public sector. Nearly every country is concerned about this topic, and BIM will not disappear so quickly. It's actually quite the contrary. Almost at the end, an example of a real building that has been realised with the help of the BIM method is the Children's Hospital in Perth, with a building volume of around 1.2 billion euros. In this case, the building owner requested the use of BIM, and REHAU was able to support its customer with the BIM data for the REHAU Titan and REHAU Piano systems. Many problems with which the participants at the Berlin airport had to deal with could have been solved or avoided with BIM. For example, there wouldn't have been an incorrect order of escalators, which are too short, and the statics would have taken the correct loads into account. As a working method, building information modeling offers many advantages, including the quality of design or significantly reduced efforts needed for coordination, cost, and time. But BIM is much more than just drawing and planning. It is also in particular a management method to handle building projects effectively, starting with the design, through the realization, then the facility management. BIM is more than a buzzword. The approach of BIM to design digitally and then build in real is already a reality and has been taken up in many areas.